Okay, we are in AP Stat, and we are in Chapter 7, and we're just going over some practice problems here dealing with some scatter plots and correlation mainly with those. And basically, again, if I'm moving too fast through these problems here, you guys just have to pause the videos and kind of jot them down to look at them and see what's going down with them. But it says the Office of Federal Housing Enterprise Oversight collects data on various aspects of housing costs around the United States. And here's their scatter plot of for each of the 50 states. The correlation is 0.65. So we're kind of looking at this, and I hope we can kind of see why it's not closer to like 1 here, because it's like, well, it looks kind of positive-ish, but how do I know where it's supposed to head? It says describe the relationship between the housing cost index, all right, and the median family income. If we standardize both values, what would the correlation coefficient between the standardized variables be? And if we had measured median family income in thousands of dollars instead of dollars, right, how would the correlation change? And Washington, D.C. has a housing cost index of 548 and a median income of 45,000. If we were to include D.C. in the data, how would that affect the correlation? And do these data provide proof that by raising the median income in a state, the housing cost index will also rise? So, take a look at this. It says, describe the relationship, and it does appear that there is a moderately strong positive relationship, and it does appear like it could be kind of linear for the most part. As the median house income goes up, the housing cost index also goes up. Part B, though, says if we standardize both variables, what would the correlation coefficient between them be? And the correlation is based off a z-score. Point being is they already told us it was 0.65. That is standardized already, so they're the same. It doesn't matter. Part C says if we had measured median family income in thousands, all right, of dollars instead, how would the correlation change? It wouldn't, because again, it's standardized, so the correlation would still be the same. That's what we have to realize with these problems. Part D says Washington, D.C., let's just say, has a housing cost index of 548 at the median income, which is right here. If we were to include D.C. in the data set, how would that affect the correlation? So it would be like maybe right around here-ish. It would be moderately high outlier. Like, it would definitely not be like right around here. It would draw it up still a little bit. So since it doesn't fit the pattern completely, like whereas if it was like right around in here, it'd be perfect, the correlation would decrease slightly as well because that's swaying it off because it's an outlier. And then part E, do these data provide proof that raising the median income in a state, the housing cost index will result in something going up? It says it looks like it's positive and it's going up. And that is all true. But the correlation, the connection between them is only 0.65, so it's not completely strong. So we can only say that the higher housing cost index scores are associated with a higher median. Their association with one another, but we don't necessarily know why. So there isn't enough proof. All right, there's probably other variables that could be at play here. So it looks like there's an association at least, but that's all that we can say. A survey was conducted in the United States and 10 countries of Western Europe to determine the percentage of teenagers who had used marijuana and or other drugs, and the results are here. So here is percent of who have used marijuana or other drugs in each of these areas. So create a scatter plot, it says, and what is the correlation between the percent of teens who have used marijuana and the percent who have used other drugs? So let's just start with the scatter plot. A scatter plot of percentage of teens who have used other drugs versus who have used marijuana. So who've used marijuana and who've used other drugs. So the point is, if you have used marijuana, it's looking like if you've used marijuana, there seems to be a fact that you've used other drugs, right? It seems to be the pattern here. Teens who have used marijuana have used other drugs. It seems to be reasonably positive. All right, is what it's looking like, and this is in the 10 Western European places. So it says the correlation between the percent of teens who have used marijuana and the percent of teens who have used them is about 0.934. All you do is plug list 1, list 2, and you can do scatterplot on your calculator. Remember, turn the plots on, you press the scatterplot button, you make sure they do list 1 and list 2, and you can take a look at what the scatterplot would look like. You would just do, when we went over this before, you basically just do the regression line, and the regression line would tell you this number as well when you plot them all in. So you can find this as well. And a correlation of 0.934, it's appearing like it's pretty linear. It's appearing like a pretty good association, but the association between the percent of teens who have used marijuana and the percent of teens who have used other drugs, it's pretty positive, and it does appear to be pretty straight, and it does appear to be reasonably strong. Countries with higher percentage of teens who have used marijuana tend to have a higher percent of teens that have used other drugs as well. And then these results do not confirm that marijuana is a gateway drug. That doesn't happen by any stretch. Can't necessarily say that. An association does exist, though, is what we're seeing between the percent of teens who have used marijuana and the percent of teens who have used other drugs. This does not mean that one causes the other. It does look like there is association. Doesn't mean, hey, if you're using marijuana, you're definitely using other drugs. It just means that there is probably some type of connection between them, an association between them. But it doesn't necessarily mean that one causes the other. If we take a look at this one, American League baseball games are played under the designated hitter rule, meaning that pitchers, often weak hitters, do not have to bat. Baseball owners believe that the designated hitter rule means more runs scored, which in turn means higher attendance. Is there evidence that more fans attend games if the team scores more runs? Data collected from American League games during the 2006 season indicates a correlation of 0.667 between runs scored and the number of people at the game. So, this is what we got. It's from here to here. It looks like it's going up. It's kind of in the middle there, but the point is, they're trying to say the more runs a team gets, how's the attendance appear to be. So does a scatter plot indicate that it's appropriate to calculate a correlation? And explain and describe the association. Well, the number of runs scored, right, and attendance are both quantities. So it does appear we could use them, right? And there doesn't appear to be too many outliers, if any. So calculating a correlation would be fine for us to find. Like, there could be some that would be vaguely outliers here. For the most part, it does appear that they're going up. So you could classify that as maybe an outlier. That is maybe an outlier. So there may be ways to classify them. So, but you can still calculate it. Part B, though, describe association between attendance and runs. The association between the attendance and runs scored, it does appear to be positive. Right? As the runs go up, it does appear to be that there's more attendance. We don't have one of those too often fluke occurrences. I mean, right here could be it, but for the most part, and even right here might be it, but they seem to be pretty clustered like in that way. So generally, as the number of runs scored increases, so does that. So there's an association between them. Notice the key word there. Does this association prove the owners are right more than they are not? There is evidence that there's an association between attendance and runs scored, but a cause and effect relationship between the two is not implied. There may be lurking variables that could account for an increase. Maybe there's a special day at the park that drew more attendance in. Maybe a specific team was playing somebody. Maybe they ended up having a high hit game or a lot of runs, and like, you don't know. There could be lurking variables. So, for example, perhaps winning teams score more runs and also have higher attendance. just because of that. They happen to be the same thing. We don't have any basis to make a claim of what might cause one or the other yet. People who respond to a July 2004 Discovery Channel poll named the 10 best roller coasters in the United States. The table below shows the length of the initial drop and the duration of the ride. What do these data indicate about the height of a roller coaster and the length of the ride? So, here are the roller coasters. These are ranked the top 10. And then with that in mind, we have their drop versus their duration as well. So, when you're looking at this, it says the scatter plot right here that they have for us, which I could just plug those in to get a scatter plot. The drop versus the duration, right? And it doesn't overly appear to be that it's maybe positive, but the scatter plot to the right shows the association for the drops and duration. It's maybe it's straightish, but it's very weak. Like it's kind of all over. It does appear to be positive. With no total outlier. I mean, you could argue that maybe some of these might technically be outliers, but generally, rides on coasters with a greater initial drop, right, tend to last somewhat a little longer, right? The drops are bigger here, they're lasting longer. The correlation between drop and duration is 0.35, so it's pretty weak. The association between them is still pretty weak, though, and you could get that by plugging each of those in. All right, when we come back here, I will take a look at correlation here with flights.